Right. I will move on to the past paper questions of the last lesson later. And as 45 minutes has passed, so I will start the new lesson today, right? Okay, now here we are going to analyze as well as the character also, right? How to represent inside the computers. Now, as an example, if you take any character that is they are in your keyboard, right? Maybe the numbers are there, characters are there, some special symbols are there, right? Normally, all are represented inside the computer in binary form, right? So, in this lesson, we are going to learn how these characters and the numbers are going to be represented inside a computer, right? Okay. Now, under this lesson, we have to discuss 4 number systems, right? The decimal number system, binary number system, octal number system, and hexadecimal number system. Now, those who have done the O-level ICT, maybe they have done all of these conversions. But in this lesson, we have to go further, right? That means in the calculations also, we have to have some complex problems as well as some more calculations that was not in the O-level we have to do here. So no, nothing to worry. Although you have not done those in your O-levels, I will explain from the beginning itself, right? Right. Now, if you take these 4 number systems, normally the decimal number system is the one that we use in our day-to-day calculations. Now, as an example, I am asking how old are you, right? So you may tell your age, maybe 17, 18, 16, and so on, right? Now that number normally you express in decimal manner, right? And all the calculations that we use in day-to-day purposes, we use this decimal number system. And the binary number system is the one that used inside the digital devices. Now, digital devices means maybe the computers, mobile phones, right? And tablets, maybe inside digital cameras, every digital equipment, they use binary number system. Now, normally a number system is consisted of a fixed number of symbols, and we use that particular numbers or particular symbols in order to do the calculation and representation, right? So octal numbers, that is again a number kind of number system in all the computers, right? The octal number system has used, but that is not used in today's computers. If you take the hexadecimal one, still the mainframe computers, it uses this hexadecimal number system, right? Now, if you take each of this number system, there are some specific features that you have to know, right? So you have to know this information regarding the number systems. The first thing you have to know is what are the symbols of each? Symbols, set of symbols for each of these number system are there. So you have to know what are the symbols of each of the number system. And then you have to know what are the place values? What are the place values of each? And then you have to know what are the bases, right? Each of these number systems, it's having a base, right? So these are the 3 main things that you have to know regarding each of these number system. Then we will move on to the calculations after discussing each of these features. First, we'll move on to the decimal number system, right? First, we'll move on to the decimal number system. Right. Now, what are the symbols of this decimal number system? There are 10 digits or 10 symbols under this number system, starting with 0, 1, 2, 3, according to the order up to 9. There are altogether 10 symbols in this particular number system, right? There are 10 symbols from 0 to 9. And if you take an example here, now I told you the decimal number system is the one that we use for our day-to-day calculations now. Now here I have represented the number 3456. And if you take this number expanded in this manner, can you remember in your lower level mathematics, you have learned the place values of each. This is we called as 10 to the power 0th position. This is the 10 to the power 1. This is 10 to the power 2. And the last one is 10 to the power 2. Sorry, 3. Right? Starting from 0 up to 3, there are 4 place values. Right? And if you analyze each of the place values here, right? What is the corresponding value of this 6 here? That is 6 into the corresponding place value. That is 10 to the power 0. And if you take the 5 here, it is not the 5. According to the place that is it resides in this particular number, it's having 50, right? The 6 is having 6, that is same. But if you take 5 here, the place value of that 5 is 10 to the power 1. So if you multiply this by 10 to the power 1, you are having 50. Now, if you are asking what is the value of 5 here, according to the place value, we have to tell that is 50, not 5, right? Same way, the 4, that is inside the 10 to the power 2's position. So the value is 400. And 3, that is 10 to the power 3 position, the third position, and that is 3000, right? So by adding all of these, again, we can make this number. So these are called as the place values, the 10 to the power 0, 1, and so on. And if you are having some fraction number like this, say 1, 2, like this, right? Now you know the starting point here is 10 to the power 0. What is this place value? 10 to the power minus 1. This one is 10 to the power minus 2. Right? So these are the place values that you can see under this decimal number system. And you have to know what is the relevant value here. Now, if you take 10 to the power 1, once you simplify that one, you can take 10. 10 to the power 0 is 1. 10 to the power minus 1 is how much? That is 0.1. These values you have to know because when you are doing the calculations, you should know how to simplify these things. That is simple mathematics, right? How to calculate 10 to the power minus 1? You have to take it as 1 over 10 here. And that is, you are going to divide 1 by 10. That is this way. Right? මොකද මේක සමහරක් අයට මතක නැතුව ඇති. ඒක නිසායි මම මේ පෙන්නන්නේ. It's a very simple one. This is 0.1. This way you have to take that one, right? If it is 10 to the power minus 2, same way you have to take it as 10 to the power minus 2 කොහමද හදන්නේ? 1 over 10 to the power 2, right? In order to drop this minus point here, you have to take it to the denominator here, right? It has a denominator, so that is 10 to the power 2. 1 over 10 to the power 2 is how much? Sorry, light gear. Right. Can you hear me?
Yes, teacher.
Right. Okay. Here I am having a power cut, but I'm having a UPS here. We'll try to do with the UPS. Right. Uh, okay. Now the place values I explained, and what is the base? Right, as this particular number system is having 10 digits, we call the base of this particular number system is 10. Okay, that is the base normally we have to take according to the symbols of the particular number system. Now, as the decimal number system is consisting of 10 digits here, we call the base of this number system is 10. Okay, now can you all remember the features, the symbols you have to know, right? And how to write the place values, you have to know like this, and you have to know the base, right? Same way, the binary number system. The binary number system, it's having two digits. As the symbols, it's having only two digits, right? In the previous case, the decimal number system, we had 10 digits. Now, here in the binary, we are having two digits, that is 0 and 1. Okay. Now, what are the place values of this one? Now, as an example, if you take this particular binary number, right? And here you can see a difference. Now, in the decimal numbers, you don't put the base as the 10 here, but in this binary number system, right, you have to specify the base here. Now, as this particular number system is having two digits, that is 0 and 1, we call the base of this particular number system is as 2. The base is 2, as this is having two symbols, right? So the base normally you have to put under the lower corner here, you have to put the base. That is a must, right? Not like the decimal number system. Now, if you take the place values of this particular one, 11010, right? You have to take the place values as 2 to the powers. You have to take the place values as 2 to the power ones, right? Starting from 2 to the power 0 again here. It's going on like 2 to the power 1, 2 to the power 2, right? 2 to the power 2 to the power 1, 2 to the power 2, then 2 to the power 3, and this one, the 2 to the power 4. Right? Same way, if you consider the fraction binaries like this, say this particular number is having some fraction part as well. In that case, again, this place is 2 to the power 0. This one is 2 to the power minus 1. This is 2 to the power minus 2. And again, the positive place values you have to put this way. Right? Very easy. Very similar to the decimal one. Okay. And what about the values of these place values? That means according to the place, they are having these particular 2 to the power 0 and 2 to the power 1, those place values. So when you are doing the calculations, you have to know how to simplify those. Now, if you take 2 to the power 0, right? 2 to the power 0 is always 1, right? Maybe the 0th power of any number, say 10 to the power 0, 8 to the power 0, 2 to the power 0, right? Anything is equal to 1. You have to remember that one here, right? And what about the 2 to the power minus 1? How to calculate that thing? 2 to the power minus 1 කියන එක කොහොමද calculate කරන්නේ? You have to take 1 over 2. That means you are going to divide 1 by 2. That is 0.5. The 2 to the power minus 2. 1 over 2 to the power 2. That means 1 over 4. You have to divide 1 by 4. That is 0.25. So you have to know how to take that values. by simplifying, right? I'm sure you know those calculation part. Uh, and here again, a thing that you have to keep in mind, each of these symbols, the zeros and ones, we normally called as bits under this particular number system. Bits කියලා කියනවා අපි මේවට, right? We call the symbols of this particular binary number system as bits. Now, if you take this particular binary number, how many bits are there? 1, 2, 3, 4, 5. Altogether, 5 bits are there. Right? If you take this one, there are 1, 2, 3, 4, 5, 6. 6 bits are there. Okay. Now, I told you in the digital devices, it uses this particular number system. How this 0 and 1 values are represented inside those devices? That is using electricity, right? Using electricity. That means when you are giving a power or kind of electricity into the device, right? It is representing 1 inside that digital device. And when you are not supplying any current to the device, that means you are representing 0 there, right? According to the power supply or the electricity, it's representing these values inside the digital devices, right? So these normal zeros and ones, those states can represent in many ways, like the 0 state, normally if you consider the power again, this is called as the off state, power off state. This is called as the power on state, right? If you take like true false, normally this 0 we called as false, right? And the 1 we called as the true state. If you can represent this as yes or no, normally this is no, this one is yes. Likewise, in binary manner, that means when we are going to the next lesson, the logic gate lesson, you will learn this binary number system further. In that case, you will learn all of these, right? So for this particular lesson, just keep in mind the 0 and 1 we can represent in some words like off and on state, right? That means the binary functions we can represent in many ways, this like this. And we will move on to the octal number system again. That is, it's consisted of 8 digits, 0, 1, 2, 3, 4 up to 7. Altogether, there are 8 digits here. That is why we call it as octal. Octa. Latin, in the Latin language, it says the 8 is represented as octa. So that is why this is represented as octal here, right? And if you take the example, this one, here an example for an octal one. You have to mention the base again here in the right corner, right lower corner, you have to mention the base. And as this is having again 8 digits, the base is 8, right? The base of this particular number system is 8 here. That base you have to represent in here in the lower corner, okay? And what about the place values? Those are 8 to the power ones, right? Now, if you take this 673, this place is equal to the 8 to the power 0. This is 8 to the power 1. This is 8 to the power 2. And if you have some, say, some fraction parts, then again you have to do the negative place values this way, right? Again, what about 8 to the power 0? That is 1, right? You have to take 8 to the power 0 place as 1. 8 to the power 1 is 8. 8 to the power minus 1, you have to take as 1 over 8. That means you are going to divide 1 by 8. That particular value we have to take here, right? When you are doing the calculation, I will show you, right? This is the summary and the features of this octal number system. And then we'll move on to the hexadecimal. The hexa means 16. In order to represent 16, we use hexa in Latin. So hexadecimal number system, it's having 16 symbols. It's like this, right? 0, 1, 2, up to 9 numbers. Up to 9, altogether there are 10 digits here. And also capital A to capital F, right? There are how many? 6 letters here. Now, this is a special kind of number system because in all the other number systems, you can see only the numbers. But if you take this hexadecimal one, both of the numbers as well as some capital letters of the English language is there, right? A little bit different than the other three. 0 to 9 numbers there. Altogether, there are 10 symbols now. 0 to 9 මෙතන 10ක් තියෙනවා, right? It's 10 digits here, as well as how many characters there? There are 6 characters. Altogether 16 symbols. As this is having 16 symbols, we call the base of this particular number system is as 16. And also you have to place that particular place value under this number like this way. Right? In binary, octal, as well as in hexadecimal, in all the 3 cases, you have to put the base like this. And what about the place values? Say this example, this point, we have to take as 16 to the power 0. This is 16 to the power 1. And if you are having some decimal values here, you have to take as -1, -2, and so on. Again, the calculations you have to do like 16 to the power 0 is 1. And 16 to the power -1 is how much? 1 over 16. You have to simplify this one and take the value. Here 16 to the power 1 is just 16. Those calculations you should know, right? So what is the minimum value of this number system? That is 0. Maximum value is F. Capital F. Don't use simple letters, only you have to use capital letters here, right? Normally, this capital A is represented 10, but don't use 10 here. You have to know instead of 10, we are representing capital A, but don't use tens in hexadecimals, right? And instead of 11, you are using capital B here. Here, this is 12. This is 30, this is 14, and this is 15, right? Normally that numbers are there for this particular characters, but don't use those numbers. You have to use these letters here instead of this 10 to 15, right? So this is the summary regarding all of these 4 number systems, right? So I'm not going to give you the note, but in the tutorial itself, it's there. First, we'll move on to that tutorial, and then we'll start doing the calculation part, right? So hope you all are having the printout of the tutorial. If you don't have the tutorial, just have some papers and write down the answers there. Then after taking the printout, you can just paste it or just write the answers there, right? Because I'm not giving a not in the class. All the things are based on this tutorial and presentation, right? Right. The number system, there are 4 number systems it has given here, and we will fill out this information in the tune, right? decimal number system. This number system has how many digits?
10 digits.
10 digits. Yes. As you have to mention what are the digits here.
0 to 9.
Yes, 0, 1, 2, 3, 4, up to 9 you have to write, right? 0, 1, 2, 3, 4, up to 9, just write everything. All the 10 digits you have to mention here. Don't put like 0 to 9. එහෙම දාන්න එපා. හරිද? Comma separating values you have to put up to 9. Then just simplify this particular expanded number. What about 3 into 10 to the power 3? 10 to
3000.
the power 3000. Just fill it out. Right now here you can see that 10 to the power 3 means the place value of this particular 3. Right? Just the simple mathematics. Grade 4 වලක් තියෙනවා නෙමෙයි. 4 into 10 to the power 2 is how much?
400.
400. 5 into 10 to the power 1? 50. 6 into 10 to the power 0?
6.
6. Because 10 to the power 0 is 1. Just keep in mind that one, right? Any numbers, the 0th power is always equal to 1. So after adding all of these, again, you can take this particular number. The place values in decimal number are multiple values of what? The place values of this decimal number are multiples of
10.
10. And just fill this down. Starting from here, 10 to the power, it should be
0.
0. To this side, the positive place values are going on. From here to this side, the negative place values are going on. And just mention the value. Now, 10 to the power 2 is 100. What about 10 to the power 1?
10.
10. 10 to the power 0?
1.
1. 10 to the power minus 1?
0.1.
0.1. 10 to the power minus 2?
0.01.
0.01. Right? How to take that one? මේක එක සැරයක් මම දැන් කියලා දෙන්නම්. very අමතක වෙලා තියෙන අයට, right? You have to take this as 1 over 10 to the power 2. You know 10 to the power 2 is 100. Right? So you have to divide 1 by 100. You have to divide 1 by 100. How much is that? That is 0. You have to take 10 as 0. Again, this one 1. Right? So the answer is 0.01. You have to take that way. Okay, what about 10 to the power minus 3?
0.001.
Oh, 0.001. Right? Next one. Oh. Right? Okay. Right. Therefore, therefore කියන එකට මෙතන එන්න ඕනේ. As this number system is having 10 symbols. Therefore, you don't take that one. Therefore, instead of therefore, you have to write this way. As this number system is having 10 symbols, the base value of the decimal number system is how much? 10. The base is 10. Why the base is 10? Because this number system is having 10 symbols, 10 different digits. That is why we call this as the base is 10 here. Right? Normally the base don't put here in the lower corner here. Don't put the 10 because in the decimal number systems you are not going to give the place value. Sorry, the base. But in all the other number systems like binary, octal, and hexadecimal, you have to put the place value. Not the place value, sorry, the base value, right? Base value. So here instead of therefore, just write by crossing this word in the upper here, just write as this number system is having 10 symbols, the base value of the number system is 10. Then the binary number system. The binary number system has how many elements?
2 digits.
Two, teacher.
Two elements which can be represented 2 states. These 2 states are represented by digits
0 and 1.
0 and 1. There are multiplications of
2.
in place values. Place values in the place values there are multiplications of
2.
2. Yes, 2 in place values of binary number system. They are as follows. So starting from again the 2 to the power 0, 1, you have to go this way as positive values and this direction negative place values. So let us fill this one. 2 to the power 0 is how much?
1.
1. 2 to the power 1?
2.
2. 2 to the power 2?
4.
4. 2 to the power 3?
8.
8. 2 to the power 4? 16. Right? Can you remember how to take the 2 to the power 3? Just multiply 2 by 2 again by 2. 3 times you have to multiply 2. Right? So 2 into 2 is 4. 4 into 2 is 8. That manner you have to take. Okay? Right. 2 to the power minus 1. How to take that one? 2 to the power minus 1 is equal to 1 over 2. That means you are going to divide 1 by 2. That is 0.5. This like that, how much to the power minus 2 is?
0.25.
0.25. There you have to divide 1 over 2 to the power 2. That means 1 over 4. 1 over 4 is 0.25. Right? Therefore, the base value of the number system, binary number system is what?
2.
2. Base is 2. As it's having 2 elements, the base is 2. Okay. As the computer works on electricity and is an electronic device, its functions are controlled by 2 states. These 2 states are where the power is
On and off.
on and off.
Off.
So the given example, you have to write down the place values. Yeah. We will start from this corner, right? The last one is 0 now. So just 0 into what? 2 to the power
1. 0.
0, right? 0. Yes. Next one, 1 into this one. 1 into 2 to the power 1. Next, 0 again. 0 into 2 to the power how much?
2.
2. Next one, 1 here. 1 into the place value is 2 to the power 3. Last one, there is 1 and 2 to the power
4.
4. So 1 into 2 to the power 4, that is 1 into 16. Just fill it out. 1 into 2 to the power 3, how much?
8.
1 into,
1 into 8.
yes, 8. Here this one, 0 into 2 to the power 2 is 0
0.
into
0 into
4.
4.
1 into 2 to the power 1 is 1 into
1 into 2.
2. 0 into 2 to the power 0 is 0 into 1 because 2 to
1.
the power 0 is 1. Right? So by adding all of these values, you can take 26 here. Middle place එකත් ඕන්න ලියා ගන්න. That is 16 here. Plus this one is 8. This one is 0. Plus this one is 2. Plus this one is 2.
0.
Altogether, 26. So don't put the base, no need of base. Have you all done this conversions in your lower grades mathematics? Is that in grade 9?
Yes, teacher.
Yes, teacher.
Yeah, you had that one. Yes. So we can go quickly. One location is, although you have not done O level ICT, all of you have followed the grade 9 now, right? So we can just going quickly. One location, that means one digit, is called what? A special name we call
It's a
here
bit.
bit. Binary වල එක digit එකකට කියනවා bit කියලා. There are bits in the above number. In this particular binary number,
5 bits.
5 bits. Then the octal number system. The digits are 0, 1, 2, 3 up to 7. Altogether 8 symbols there. So just fill this one. Starting from 8 to the power 0. This place is 8 to the power 1. Yes. Here.
8 to the power negative 1.
Yes.
8 to the power negative 2.
2. Yes. Right. Then the values. 8 to the power 0 again. That is 1. 8 to the power 1, how much?
8.
8. 8 to the power 2?
64.
64. That means 8 into 8. 8 to the power 2 can 8 to the power 3?
512.
212.
200 and
512 teacher.
512. 512. That means 8 you have to multiply 3 times. 8 into 8 is 64. 64 into 8 is 512. 1 over, here 8 minus 1 means 1 over 8. What is the value there? That is equal to 1 over 8.
0.25.
0.25 then.
Yes, teacher.
125, eh? 0.125. That's all. The next one, 1 over how much?
64.
64.
64. That is how much? Just divide this 1 over 64. 0, 1, 64. See, that is here. හයක් නෑනේ පහයිනේ. We can't exactly divide this one. Roughly you have to take 7ක් නෑනේ 6ක්. This side. Maybe 0.0156. Roughly you have to take, right? Then the example given, just write down the place values. That is 7, this one, 16, 6 into 8 to the power 2, 7 into 8 to the power 1, 3 into 8 to the power 0. Now what about here? 3 into 8 to the power 0 is how much?
1 teacher.
1 teacher.
Metana 6 into 8 to the power 2 is
64.
64. Just simplify and you can take the final answer again as 673. The base value of octal number system is base 8.
8, teacher.
This is 8, yes. Then the hexadecimal number system. There are digits in the hexadecimal. How many?
16
Digits කියන්න බෑනේ. We
digits.
call as symbols. Because symbols කියලා දාමු. Because not only the digits there, digits means numbers only, no? Digit කියන්න බෑ. So there are 16 symbols. Just take it as symbols, right? Because both the numbers and alphabetical characters are there. As what are the characters? What are the symbols?
0 1 2 3 4
0 to 16.
0, yes,
1,
0, 1, 2, 3. Let's write it up to 9, comma, as well as you have to write down the capital letters up to F. Please write all of the parts without missing. The minimum value is how much?
0,
0.
0
Maximum value?
15
F.
F, teacher.
Capital F. So because we can't take 15, but it's represented as 15.
F.
Maximum value kiwama don't take 15. Just write that set F, capital F, right?
okay teacher.
The place values are fellows. Yes, we'll start from here. 1 means what is the place value?
16 to the power 0
Yes, this one.
16 to the power 1.
Here.
16 to the power negative 1. 16 to the power negative 2.
Yes. So we'll write down the values. 16 to the power 1 is
16.
16
16 to the power 2.
256
Then 16 to the power minus 1 means 1 over 16. 1 over 16 here. Again, just simplify it later. Here, 1 over 256.
56.
The base value of hexadecimal number system is 16. The example is this one. Right. Now, the summary is like that. So we'll move on to the next one because you can just easily fill this out. Grade 9 maths now. If it is a kind of O-level related one, I will explain. But this is just mathematics in grade 9, so no need to explain specifically. Yes, the PowerPoint.